Imagine standing beside the Great Wall of China, stretching across mountains, valleys, and deserts. It is one of the most remarkable structures ever built. But hidden inside parts of this enormous wall is something you might never expect to find. Rice. More specifically, a sticky rice-based mortar was used by ancient Chinese builders. So how could something as ordinary as rice help hold together one of the greatest structures in human history? The story goes back more than 1,500 years, when Chinese builders were developing stronger ways to construct walls, roads, and other structures. Traditional mortar was usually made from materials such as lime and water, but ancient builders discovered that adding a surprising ingredient could improve the mixture. That ingredient was sticky rice. Sticky rice, also called glutinous rice, contains a type of starch called amylopectin. When the rice was cooked and mixed with lime, the starch interacted with the lime and helped create a mortar that could become remarkably strong and durable. Researchers studying ancient construction materials have found evidence that this type of sticky rice mortar was used in historic Chinese buildings and walls. The discovery is especially fascinating because the builders had no modern knowledge of chemistry. They didn't know about molecules, polymers, or the detailed chemical reactions taking place inside the mortar. Instead, they relied on observation and generations of practical knowledge. They discovered what worked and passed that knowledge on. But there is an important detail. The Great Wall wasn't built all at once. It was constructed, rebuilt, and expanded by different dynasties over many centuries. Different sections were made using different local materials and construction techniques. Some sections were built from packed earth. Others used bricks and stone. So sticky rice was not the secret ingredient in every part of the Great Wall. Instead, researchers have found evidence of sticky rice-based mortar in certain ancient Chinese construction projects, including sections associated with the Great Wall and other historic structures. The technique was particularly clever because the mortar had to perform in difficult conditions. Walls were exposed to rain, wind, temperature changes, and the weight of enormous stone and brick structures. A mortar that could resist deterioration was extremely valuable. Modern scientists have even studied the ancient mixture to understand why it worked so well. The combination of lime and sticky rice starch created a composite material with useful properties. In simple terms, the rice starch helped control the growth of certain crystals in the lime-based mortar, contributing to its strength and durability. And this is where the story becomes even more surprising. Something that people normally eat was being used as an advanced construction material. Imagine ancient workers preparing enormous quantities of rice, cooking it, and combining it with lime, not to make dinner, but to build walls that would survive for centuries. The technique shows just how much knowledge ancient civilizations could develop through experimentation. They may not have had modern laboratories, but they had something equally important: experience. They observed materials. They tested mixtures. They learned from failures. And eventually, they discovered combinations that could withstand the test of time. The Great Wall itself is a monument to this kind of engineering. It was never simply one wall. It was a huge network of fortifications built across an enormous landscape. Millions of workers, soldiers, laborers, and craftsmen contributed to its construction and maintenance over different periods. And hidden within some of its ancient masonry is evidence of a surprisingly sophisticated material technology. So the next time you see the Great Wall of China, remember that its secrets aren't only found in its towers and mountains. Some are hidden between the bricks. And one of those secrets is sticky rice, a simple food that ancient builders transformed into an ingenious construction material. More than 1,000 years later, the walls still stand. And perhaps the most remarkable part is that one of their ingredients could have been sitting on an ancient dinner table.